question about the paradox. Why is Mary younger upon reunion? Well, it's because our typical rules of relativity only apply for inertial reference frames, which Botan's perspective is and Mary's isn't. But philosophers never stop asking why, and when we do that, it might lead to even more insight about the paradox. So, why is Mary's reference frame not inertial? Well, it's because she accelerates to turn around. But why is Mary the accelerating one and not Botan? This is actually pretty straightforward. If we equip Mary and Botan with accelerometers, then Botan's will never indicate any acceleration other than gravity, which, as I mentioned earlier, has no significant role in this example. Meanwhile, Mary's accelerometer will report nothing for most of the trip, but consistent acceleration for the duration of the turnaround. Now keep in mind, the accelerometers themselves are technically superficial. The important thing is what they demonstrate, is that only Mary ever experiences acceleration without a source of gravity, which is known as a fictitious force. The only conclusion from this is that Mary accelerates and Botan never does. Both of them agree on this because in relativity, acceleration is absolute. But why does Mary's accelerometer indicate acceleration and not Botan's? The only real answer to this is because we say so. The way we phrase the paradox is that the space twin leaves in their ship and then turns around and comes back. And in real life, here on Earth, we don't just inexplicably accelerate unless we're in an accelerating reference frame, such as a spaceship. Due to this, it's pretty much subconsciously agreed upon that the space twin accelerates and the Earth twin doesn't. But what if we don't subconsciously agree on it? Well, this is how we get the third version of the paradox, the philosophical version. This time, we get rid of the star and Earth and all the numbers. All we know is that you have two observers that start off together, then become separated, and then reunite. You have no idea who accelerates or by how much. This version is by its very nature unresolvable, making it a true paradox. As for the original version, since we subconsciously agreed on who accelerates, there's no contradiction, and the outcome is in a sense already decided. Depending on your definition, this technically makes it only an apparent paradox, not a true one. Now, when people define what the twin paradox is, the conventional presentation is this apparent version, including the Earth, the spaceship, and the subconsciously agreed upon acceleration of the space twin. Despite this, some people insist the only true twin paradox is instead the philosophical version. Some people even go so far as to say the apparent version is pointless to explain because the answer is obvious if you've already agreed on what it is. However, I strongly disagree with it being obvious or pointless to talk about. Instead, I believe everyone deserves a chance to learn relativity, and that intentionally avoiding any non-philosophical discussions of it is counterproductive to making any real progress in scientific education. Anyway, let's get back to the paradox. As I mentioned earlier, the philosophical version is by its very nature unresolvable. In that case, the question becomes not who is the younger twin, but instead why is this unresolvable? Specifically, there are two main philosophical concerns. One, how can we have absolute acceleration but not absolute velocity? And two, how can they both observe each other aging slowly or events in different orders when it seems inherently contradictory? Well, the thing is, from a scientific perspective, it doesn't really matter. The concept of time is simply a useful tool to help us make predictions. The fact that it behaves like this may be counterintuitive, but it doesn't cause any actual contradictions in real life, as we've seen numerous times. But if you're trying to understand the true philosophical meaning of time, then these rules of relativity might clash with your own philosophical interpretation of time. And in that case, if you don't want to just accept that's how the universe is, then there do exist alternative fringe theories that oppose relativity and include things like absolute velocity and simultaneity. The thing is, these theories must make the exact same predictions as relativity, i.e. the ones that have matched decades of experimental evidence. That makes them equivalent to relativity, because there's no experiment that could prove one over the other. When competing theories have the exact same predictive power, scientists just go with the one with fewer assumptions, which is why relativity has stood the test of time and is still the dominant theory over a century later, even if you don't find it philosophically satisfying.